Good evening, guys. In the previous session, we have seen what is monitoring, cluster monitoring, and application logs monitoring. Okay, so we are deploying our applications on Kubernetes cluster. Master node will be available and worker nodes will be available. This cluster we can create as a self-managed cluster, or we can go for EKS cluster. So currently I am using EKS cluster. When we go for EKS cluster, provider will manage the control plane. We need to manage just worker nodes that are required in our cluster. Fine, our cluster is running. Inside this cluster, I want to install few applications. Inside the cluster, I want to install few applications. In order to install the applications on the cluster, I am using Kubernetes package manager. So we are using Helm as a package manager for our Kubernetes, right? Helm chats we are using, Helm chats we are using, Helm charts we are using to install applications on the cluster. So in the last session, we have seen what is Prometheus and what is Grafana. Prometheus is a monitoring and alerting toolkit that we are going to install as a pod in the Kubernetes cluster. So this Prometheus can monitor our cluster nodes and will give the alerts. It will generate the data source, right? Grafana is a visualization software. Grafana is going to take the data from the Prometheus and it is going to present the data in the beautiful charts format and graphs format, right? So we installed Prometheus and Grafana as Helm charts on our Kubernetes cluster. Then after, we have seen what is ELK stack. The ELK stack is a collection of 3 open source products like Elasticsearch, Logstash, and Kibana. So what is the main reason of going for this ELK stack? ELK stack is used to monitor application logs. When the application is running in the production, there is a chance of getting several issues due to some code or due to servers or due to database. Reason can be anything. There is a chance of getting problem, right? When the problem occurred, in our application, developer should fix that problem. Developer should fix this problem. Developer should fix this problem. Developer should fix this problem. In order to fix the problem, developer should understand where is the problem. To understand the problem, developer should check the log file. So here, application will be running on the cluster, logs will be generated on the cluster. So developers cannot access the logs which are available in the cluster directly. So that's why we are going to expose application log files by using ELK stack so that the developers can access. So yesterday I have shown you how to deal with Splunk in our application. Okay, this is our cluster. In our cluster, our application is running. This in our cluster, our application is running. This application will generate the logs. Every application will be generating a log file. For every application, one log file will be available. So developers cannot access this log file directly, which is available in our cluster. So that's why in the companies, these log files will be connected to either Splunk. Some companies, the MNC companies who are having a budget from the client, those people will go for Splunk software. Application log will be connected to Splunk commercial software. If the client does not give the budget for this infrastructure, then we can go for open source products to set up this logs, EFK or ELK, something like this. This log file will be connected to Splunk or EFK. Splunk is a commercial software and EFK is a open source. Application is executing on the cluster. As part of that execution, log file will be generated. Application details, application execution details will be available in the log file. Now, here development team will be available. Whenever a issue occurred, the development team members will be connected to the log file of the application. by using Splunk or by using EFK stack. Okay, so if your project is having Splunk, then Splunk admin will be available. Splunk admin will connect your application log file to Splunk software. Developer will get the access for the Splunk, then developer will access logs from the Splunk. If the Splunk is not available in your project, then developer will get the access for EFK stack. Developer will connect to the EFK stack and will get the logs of the application. So he is developer. So he will understand the logs of the application and he will fix the problem. He will understand the logs of the application and he is going to fix the problem. Okay, guys, are you clear with my point? Are you clear with my point? Application will be running on the cluster and application will generate the log files. Logs files will be connected to a Splunk or log files will be connected to EFK. So what is this EFK? E stands for Elasticsearch, F stands for file beat, L stands for Logstash, K stands for Kibana. Kibana is a visualization software which is used to retrieve the logs from the Elasticsearch. Elasticsearch is a data store which is used to store the logs, right? Logstash is used to retrieve the logs from the application log file and send it to Elasticsearch. Kibana is a visualizer software. Good. In the last session, we have done the installation of our EFK stack by using Helm charts, right? We created one custom namespace. We created one custom namespace with a name called EFK. I created a custom namespace with a name called EFK. kubectl create namespace EFK. kubectl get the namespace and I added Elastic repository to the Helm chart. Then I have downloaded Elasticsearch values. I modified the replicas and master nodes and I installed Elasticsearch. Once the Elasticsearch got installed, then I have downloaded the values of Kibana. Kibana is a web application which will provide the visualization to monitor logs of your application. Okay, fine. So Kibana, this will be available by default as cluster IP, but I want to access the Kibana outside of the cluster. That's why I will change the service type of the Kibana to load balancer and I will give the port number as a 80. After this, Kibana got installed. After Kibana got installed, in order to collect the log files from the machines, I'm going to use a FileBeat. FileBeat will be installed as a daemon set. It is going to install as a daemon set. What is the daemon set? It will be installed on every node and it is going to collect the log files and it will be sending the log files to Elasticsearch. Kibana will be connected to Elasticsearch and Kibana is going to get the logs from the Elasticsearch and it is going to present the logs. Okay, so yesterday we have already done that installation on my EKS cluster. Right, in my cluster, 2 worker nodes are running. Control plane is managing by AWS. We don't have any control on the master node. We have the control only on the worker nodes. And we installed a cluster on the EKS, right? And we created a client machine to access that cluster. Right, let's connect to this client machine where EKS cluster is configured. Where EKS cluster is configured, go to this host, username, EC2 user, advanced SSH settings, use a private key, Linux PEM file, click on OK, click on OK. Yeah, fine, ls-l. Okay, we have our client machine ready. kubectl cluster info. Yes, my control plane is running on the AWS EKS. So cluster is running here. kubectl cluster info, I'm able to access the cluster in the client machine. kubectl get nodes. So there are 2 nodes are running. There are 2 nodes are running. kubectl get nodes. 2 nodes are running. Now kubectl get SVC. See the services currently running. So currently alert manager service is available, that is none. Kubernetes predefined service is running and one of my Java application is running as a load balancer. My Spring Boot web application is running. Spring Boot web application is running on the Kubernetes cluster. So if you want me to delete that, kubectl delete SVC. I will delete this application and I will install it once again. No problem. I'm deleting my application which is running in the Kubernetes cluster. I will show you how to deploy Spring Boot application on the cluster. And I will show you how to monitor the logs also. Yes, it is getting deleted, guys. It is getting deleted. Now, inside my cluster currently, nothing is available. Only Helm available and the Helm charts deployed. Okay, kubectl get svc, kubectl get svc. Now see here, currently only default service is running. That is a Kubernetes service. Let's go to EFK stack, kubectl get all -n EFK. EFK is the namespace I have created in my cluster. Namespace nothing but cluster inside the cluster. Inside the Kubernetes cluster, I created EFK stack. Inside the EFK, I installed Elasticsearch. I installed Kibana. I installed Filebeat. All the EFK stack I installed, all the EFK stack I have installed in a namespace called EFK namespace. All right, now kubectl get svc -n EFK. What are the services running now? Elasticsearch service is running and Kibana is also running. Kibana service by default will run as a cluster IP. So yesterday I told you to change that Kibana to load balancer. When we change that to the load balancer, one load balancer will be created. Yesterday itself we have installed it. If you go to here, one load balancer is running. This is the load balancer of our Kibana. So using this URL, we can access our Kibana web application. Let's access our Kibana web application using this load balancer DNS. Copy the DNS load balancer of Kibana, access it. My Elastic EFK stack Kibana is loaded. Okay guys, Elastic Stack web application is loaded. I installed Kibana. That Kibana I'm able to access in my browser. Where is this Kibana running? Where is this Kibana running? Kibana running on my Kubernetes cluster. So here I have installed my EFK stack. So instead of Logstash, I have taken Filebeat. So that Filebeat is installed as a daemon set. That Filebeat will be available in all the nodes. So wherever the application is executing, logs will be generated, right? All the nodes, the logs are from all the nodes it is going to collect and it will store into Elasticsearch. Elasticsearch will maintain the logs. And I have Kibana. Kibana is a UI application. Kibana will take the logs from Elasticsearch and will present to you. So here we have done the installation process of all this EFK stack. Kibana is running as a load balancer service. So for the load balancer service, one external IP generated. This is the DNS of load balancer. Using that DNS, I'm able to access this Kibana UI. Okay, Elastic Stack I'm able to access. Now here, guys, currently, do we have any application running kubectl get svc in the default namespace? In the EFK namespace, my EFK stack applications are running. But inside the default namespace, do we have any application running? We don't have any application running. So today I created one Spring Boot application, guys. I told you that, right? I will make one application ready with the log messages. Today afternoon, I have created one Spring Boot application and I pushed that Spring Boot application 11 hours ago. 11 hours ago, I created one application with a name called SB Web App and I pushed it into Docker Hub. I pushed this application into Docker Hub, ashokit/SB Web App. Now, using this Docker image, I will run my application on Kubernetes cluster as a service. For that, I have created one deployment manifest file. So if you see ls-l, there is a deployment manifest file is available, which is sbwebapp.yml. Let's go for this. vi sbwebapp.yml. You see this? There is a pod deployment manifest file available and the service is also available. API version kind I am giving as a deployment, SB Web App deployment, one replica. Name I am giving as SB Web App, SB Web App pod. Image name I am specifying as ashokit/SB Web App. This image is available in my Docker Hub. This image is available in my Docker Hub, ashokit/SB Web App. It is my Spring Boot application which contains some logs. Container port I'm giving as 8080. Right, the image is ready. So this image I'm using to create a pod. For the pod, I'm using deployment strategy. Okay, I'm using deployment kind to execute this pod on the Kubernetes cluster. Now, pods will be accessible only within the cluster by default. So I'm exposing the pod outside the cluster by using a service. So pod manifest is available, service manifest is available. In the service manifest, I'm giving the type as a load balancer. Okay, now my deployment file is ready. How to create a deployment on the cluster now with this manifest file? My manifest file contains pod specification with the deployment and a service specification with a load balancer. Okay, currently how many load balancers available in my AWS? One load balancer, that is Kibana load balancer. Kibana I installed using Helm chat as a load balancer. So I have that load balancer DNS. Using the DNS, I'm able to access the Kibana application, which is running on my cluster. Next, I want to deploy one application. As I told you, in the Docker Hub, I have a image. My image name is ashokit/sb web app. You can also access the same image, right? Let's go here. Let's create a deployment. kubectl apply -f kubectl apply -f sb web app.yml. Using this YML, I created one deployment. So what is the deployment type I have given? Service is load balancer. So one load balancer will be created in my AWS. See here, one new load balancer got generated now. Earlier we are having only one load balancer. Just now one more load balancer got created. So using this load balancer DNS, we can access our application which is running on the Kubernetes cluster. Before that, let's check the services. kubectl get service. Default, under default namespace only, my SB web app service got generated. It is got created. Service type I have given as a load balancer. As the service type is a load balancer, on the EKS cluster, AWS load balancer got created. Guys, you can't practice load balancer on the self-managed cluster. You need to go for load balancer when we are using managed clusters. Right. My service is created. Deployment is created with service type as a load balancer. DNS also generated. Let's access this application which is running on Kubernetes cluster using the load balancer DNS. Yes, you can see my application is available. Welcome. I have created this project by using Spring Boot, guys. Welcome to Ashok IT Bookstore. You can add the book details and you can view the books also. This is my application which is running on the cluster. You can also access this application. Can you guys access this application using DNS? Let me know. Are you able to hit the URL? Is the project running on the cluster? Spring Boot application. Is it accessible for you? Is it accessible for you? Yes. It is accessible for us. Okay, let me add some book details. Hibernate, author name is Gavin King, book price is some 200. Click on submit. Book saved successfully. Go back. Now I can add one more book, Spring, Rod Johnson, price 1000. Click on submit. Book saved successfully. Go back. Right, my application is running. When my application is running, it will generate some logs in the background. Okay, for example, if application is executing perfectly, there is no point of checking the logs. When the developer should check the logs, when application is giving some problem. Now, suppose for example, when I click on view all books, I'm getting a problem. Internal server 500, project is failing. See here, in my project, there are two functionalities are available. One is add book, another one is view books. When I execute add book, the books are getting added successfully. I'm not getting any problem successfully. Book saved successfully. Go back. When I click on view books, there is an error. The problem is coming. So here, whatever the problem we are getting as a DevOps engineer, are we going to fix that problem? As a DevOps engineer, are you going to fix the problem, whatever the exception coming in the project? Do you know how to fix that problem? Do you know how to fix that problem? Are you developer or you are a DevOps engineer? Are you a developer or you are a DevOps engineer? You are a DevOps engineer. So what is your duty? Deploying the applications is your duty. If the application code is not working, that is the developer duty to fix the problem. Now, where is the application running? Where my application is running now? Is application running on local system? Application running on Kubernetes cluster in the AWS cloud? Application running on the local system? Application running on the Kubernetes cluster? Come on, guys. It is running on the Kubernetes cluster. Can developer access Kubernetes cluster and can see what is the problem? No. Now see here, in the Kubernetes cluster, application is running. Application will generate a log file. Developer implemented the logs. Developer implemented the logs. The logs are connected to EFK. Log file is available on the cluster. EFK stack is also available on the cluster. Now, for the developer, we will give the access for the cluster or we will give the access for this Kibana. For developer, we will give the access for the cluster or we will give the access for Kibana. Only for Kibana, right? By using Kibana, developer should check what is the problem in the project. Developer should check the log file. Okay, checking the application logs is the developer duty or it is DevOps engineer duty? Developer duty. As a DevOps engineer, what we have to do? We have to deploy our application on the cluster and we have to install EFK stack on the cluster and developer will access that Kibana and he will search the log files. How the developers are going to search the logs by using Kibana? Let's observe. My application is getting executed. One functionality is working perfectly. Another functionality is failing. I have done that wantedly, John Buchke. I am giving the exceptions in the code. Click on submit. Book saved successfully, go back. When you click on view books, it is failing. One functionality working successfully, another functionality is failing. My application is running on AWS cloud with the EKS cluster. My project is running on Kubernetes cluster now. Good. Fine. Application is executing. People are accessing the application. Some functionalities are working, some functionalities are failing. Then what the developers will do? Developer will go to that EFK stack and a developer will check the logs, right? By using this Kibana. So where the Kibana is available? Where the Kibana is available? Kibana is available in Kubernetes cluster. Where the application is running? Application also running on the cluster. Kibana is running on the cluster. Application is also running on the cluster. So here Kibana will get the logs directly from the application or Kibana will get the log from Elasticsearch. Kibana will get the logs from Elasticsearch. Who is giving the logs to this Elasticsearch? Logstash or FileBeat. I have installed FileBeat. So what is FileBeat? How the FileBeat is executing? FileBeat is executing as a daemon set. What is the meaning of daemon set? What is the meaning of daemon set? kubectl get svc, kubectl get svc -n efk. You see here my file beats are going to execute. So what that file beat is going to do? What is that file? kubectl get all -n efk. Here we have here file beats, right guys? Right. File beat is available. How the file beat is running? File beat is running on one worker node. File beat will be running on all the worker nodes. File beat will be running on one worker node. File beat will be running on all the worker nodes. File beat will be running on all the worker nodes. How come file beat is running on all the worker nodes? File beat is executing as a pod. What type of a pod it is? It is a daemon set. We already discussed what is daemon set. A copy of the pod will be executed in all the worker nodes. Now, this file bit is executing in all the worker nodes. This file bit is going to get the logs from all the worker nodes. Wherever the logs are available, it is going to store the logs to Elasticsearch. Okay, from the Elasticsearch, Kibana is going to get the logs. Do we really need to store the logs here, or logs processing will be taken care by FileBit by default? FileBit will take care of reading the logs from the log files and store into Elasticsearch. So Kibana will connect to the Elasticsearch and it is going to get that. Now let's go to Kibana. Now I'm accessing my Kibana as a web application. It is running on the cluster as a load balancer service. So here go to observability section. Go to observability. Now when it comes to observability, consolidate your logs, metrics, application traces, and system availability with the purpose built UIs. Now go to observability. When you go for observability, it is see logs rate per minute. How many logs are generating per minute? 46 logs are generating per minute. That means so many people in this class accessed my application. When my application is accessed, it is generating a log file. You can check the logs. Last 15 minutes logs you can check. Today logs you can check. This week, last 15 minutes, last 30 minutes, last 1 hour, last 24 hours, last 7 days, last 30 days, last 90 days, last 1 year. Like that you can apply and you can check the logs. Now see, log rate is increased to 48. Earlier it is 46. Now it increased to 48. The reason people are accessing my application. Now see 49. So you guys are accessing my application. You guys are accessing my application. Whenever you access my application, the logs count is increasing. So whenever you access my application, log count will increase. See here, log count is increasing because you guys are accessing my application, logs are getting increased. Now here, if you want to see the logs, there is a concept called stream. When you click on the stream, application logs will be displayed here. Now you see application logs are displaying. Today's logs are displaying here. Last 1 day. If you want last 15 minutes logs also, you can check. Today logs you can check. Show dates, you can check it. Logs. Application logs are displaying. Developer will check this log and developer will understand what is the problem. Developer will check this log and developers will understand what is the problem and they are going to fix that problem. They're going to fix that problem. View details, timestamp, log message will be available. These all are the details of that. Log message will be available. This application is running on the worker node. Okay, it is available in the Mumbai region. Availability zone 1A. Application running on the Linux machine, T3 large instance, right? Log message. Here actual message is available. Explore this message. View event with filter. If you click on this message, the developers will understand what is the problem. For this status code is 200. They can do the investigation. View stats in uptime. Like this, they can do investigation on these log files. Stream live logs it is going to print. If you are accessing, logs will be keep on generating. This is live streaming of the logs. Whatever the application that whatever the requests are coming, based on that it is going to print those logs. Are you clear? Live logs will be executed. View all logs. Now if you see, the live logs will be streamed here. Live update now, logs. Live logs will be printed. Okay guys, how the people will do logs monitoring in the real time? You understand? Just to jump to most recent logs, log entries. Log entries. Got it. Stop the live streaming. You can stop the live streaming. Last 1 day, right? Last 1 minute apply. Last 1 minute logs also you can get. Right. Like this, you can customize your streaming according to your requirement. You can customize your streaming according to your requirement. Text size large or medium or small, wrap long lines like this. You can stream the logs. You can stream the logs. Now the logs are coming here. This is a Kibana log monitor. See here, there is an exception here. Request processing failed, nested exception, arithmetic exception, dividing by 0. So developer will see this exception, developer will understand, okay, somewhere in the project, arithmetic exception is coming, because wantedly I have created that exception. When you click on view all books, arithmetic exception is coming. Internal server 500 server is failed. So when developer check this log, he will understand that nested exception, request processing failed, java.lang.arithmetic exception dividing by 0. In this application, the programmer is writing a code where he is dividing the number by using 0. Because of that dividing by number 0, that request got failed. The code is having a problem. Now, by using this log file, developer will understand the problem. Developer will go to that code and the developer will fix the problem, and he will give the latest code. Once the issue is fixed, again we need to do the redeployment of our application. Arithmetic exception by 0. See here where this arithmetic exception is coming. in.ashokit.controller book controller view books. So here the functionality is view books. When you click on view books, here in the book controller class, there is an exception book controller.java 38 line number. Let me show my code also. Whatever the application I created, in that code, in the line number 38, there is a problem. Are we able to see the problem in the log file? As a DevOps engineer, you may not understand the log file, but developers will understand the log file. Let me show you the project. In this batch, there are some Java developers also. So the class name is book controller. Today morning, I created this application to demonstrate on the log monitoring, guys. This project is created by using Spring Boot with the Timeleaf UI. Go to controller, book controller. When you click on view books, that controller method will execute. In that method, I created one exception manually. Now see line number 38, there is a problem. When you click on view books, in this functionality, this code will execute. In this code, what I am doing, I am dividing a number by using 0 to give some exception so that I can show you how to track the logs. Line number 38, very clearly Kibana is telling in the line number 38 book controller, the code is having a problem. The class name is book controller. In the book controller class, the code having 38 line number code is having a issue. In the line number 38, I am dividing a number with 0. It is giving arithmetic exception. So this issue I am able to see in the log file. How I am searching the log file? As a developer, I am accessing the log directly in the cluster, or I am accessing the log by using EFK Kibana, where I am seeing this exception data. Guys, come on, speak out. Can you guys unmute your mic and tell me where I am checking this log file now?
EFK.
In Kibana.
In the Kibana. How the log file came to Kibana? Are we doing any connection to get the log file to Kibana, or it is coming by default?
It is coming by the log state.
That is FileBeat. What we installed to get the logs? FileBeat. FileBeat is getting the logs from the every node. From every node, FileBeat is going to get the log file, and it will store the log file by using Logstash. It is going to store the log file into Elasticsearch. What is Elasticsearch? It is a storage. Just the logs, whatever the logs generated by my application. Currently, one application is running, that is one microservice. If I have multiple microservices also, the FileBeat is going to get all the logs from all the microservices. Yes. As a DevOps engineer, do you need to do anything to get the logs from the application and to store into Elasticsearch, or by default it is taken care by FileBeat?
By default,
It will take care of it.
By default, this FileBeat is going to take care of getting the logs from the application and store into Elasticsearch. So now in my cluster, I created a namespace. In that namespace, I installed FileBeat, I installed Elasticsearch, I installed Kibana. This is called EFK stack, right? So now Kibana is running as one load balancer service. So using the DNS of that Kibana, I'm accessing that. I'm going to observability. I'm checking the logs live streaming. When I check the logs live streaming, when users access this functionality, it is giving a problem. Developers should understand what is the problem. So when the developer go to Kibana UI, when he stream the log, can he understand this problem? in which program the problem is coming? Clearly it is telling. In our project, there is a class called in.ashokit.controller.bookController. View books method is available. In that method, line number 38 is having a problem. When I open my code in the IDE, you see there is a class called in.ashokit.controller.bookController.java. This project is having a class called bookController. In that bookController view books method, in that method line number 38 having a problem. Can you see the problem here? Can you see the problem here?
Yes.
Yes, there is a problem. When there is a problem, then what the developer should do? What the developer will do?
They need to fix it.
They will fix the issue. They will test it in the local. Once issue fixed in the local, they will commit the code to Git repository. Then developer duty completed. Developer will check the issue. Developer will fix the issue. Developer will test it. Developer will push the code to Git repository. Developer task is completed. Now DevOps engineer work will start. Once the code is modified in the Git repository, then what should we do? When the code is modified by the developer in the Git repository, what we need to do now?
You need to build that code and deploy.
Yes.
Redeploy.
Redeploy that code. So code is pushed to Git repository. Are we taking the code directly from the Git repository to do the deployment? Or we are taking a Docker image to do the deployment?
Docker
Docker image.
Docker image we are taking. So what we need to do first?
We need to rebuild
We
the
need
Docker
to-
image.
Yes, we need to rebuild the Docker image. We need to push the Docker image. Then we need to redeploy our service in the Kubernetes cluster. You understand the process now?
Yes.
So now here I'm creating a deployment directly from the Git repository code, or I'm creating a deployment by using a Docker image.
by using Docker
Docker
My
image.
image Docker image. Where is my Docker image available?
Docker.
Docker Hub.
hub.
My Docker image available in the Docker Hub. Now I told you that I'm going to explain one end-to-end project, right? So here, when the developer modify the code in the Git repository, my Jenkins job should execute automatically. My Jenkins job should create the Docker image. My Jenkins job should deploy the project into Kubernetes cluster automatically. That is end-to-end project scenario. Currently deployments we have automated, or we are doing the manual deployment on the cluster?
Manual
Manual.
deployment.
Manual deployment. But in the real time, people will do the manual deployment, or people will do the automated deployment?
Automated
Automated.
deployment.
Automated deployment. Who is going to automate our deployment? Which tool we are going to use to automate our deployment?
Jenkins.
Jenkins. So what we need to do now? Jenkins we need to integrate with Docker and Kubernetes. Then our project will be ready.
Yes, sir.
You got the clarity?
Yes, sir.
Yes.
Now you understand how to work with EFK, how developers will do the log tracing?
Fantastic, sir. Thank you.
Excellent. This is called real time, guys. There is nothing like real time. Whatever we have done, this is real time only. I have taken one application. I have done the coding of my application. So that is the advantage. Here I'm a developer. So we know how the application code will be there, what type of exceptions we are going to get in the code. I have created one Spring Boot application. I have created a Docker image for application, and I have deployed my application to Kubernetes cluster using EKS cluster. Now my application is failing. There is some problem. Wantedly, I have created the problem in the code to demonstrate how to do the log tracing. Okay, now I installed EFK stack on my cluster. So when the application is accessed by you, when you click on this functionality, it is giving you a problem. In the code, there is a problem. How developer will understand this problem? Developer will go to Kibana. Developer will do the log tracing, log searching. So some companies will use EFK free source. Some companies will use Splunk. Splunk I can't explain you here because it is a commercial software. I have given you one video yesterday how the Splunk will be used by developers to monitor the logs. Now you got the full clarity?
Thank you, sir.
Yes.
Guys, are you happy now? How many of you are not aware of this process who are working in the company, how log tracing will done by the developers like this? Now tell me, if you are just a developer, is it sufficient to survive in the IT nowadays?
Nothing, sir.
If you just do the only Java coding, is it sufficient? If you are just a developer, then how you will understand logs monitoring, how you will understand this Elastic Kibana, how you will understand the cluster, Docker images, GitHub repositories, deployments. That is the reason companies are expecting full stack development. Companies requires people who are all-rounders. Companies are looking for the people who can do from development to till deployment. In my current company, we are doing that. We don't have a separate DevOps team because it is a product-based company. We are responsible for everything. So in my company, whenever I get a issue, then what should I do? If I get this kind of issue in my project, what should I do? I should go to code. I should check the log. Where is the problem? I need to fix the code. I need to push the code into Git repository. I need to go to Jenkins. I need to deploy. I need to execute the Jenkins job, which will create a Docker image. That Docker image will be deployed to Kubernetes cluster. End-to-end deployment, coding to till deployment we are doing. That is what companies are expecting nowadays. Clear, guys? If you learn the DevOps from only a DevOps engineer, can he explain these logs, monitoring, exception details and all? No. As I know the development also, I am able to give you this much clarity. You got it now? What is log monitoring and what is EFK stack? Anybody not able to understand? Any questions?
Sir, I have one question.
Yeah, please.
So like we can see these logs in ELK stack, but
Yeah.
how we can see these logs inside the Kubernetes cluster?
In the Kubernetes cluster, you need to go and check it in which pod your application is running. You need to check the logs from the pods.
Okay,
Right.
understood.
kubectl logs pod name you need to give. This application is executing in a pod, right? The pod logs you can check it, but we don't check the logs from the cluster directly, guys. We will check in the Kibana or Slack or Splunk because we will not have the direct access for the clusters, right?
Correct.
Yep.
Thank you.
Any questions, anybody on the log tracking, log tracing of our applications?
So that ELK, your video is there, no, sir. Please share that URL in
Which one?
that yesterday you show that video, no? Your video, sir.
Splunk video. Splunk video. Yeah, it is already there in the YouTube, sir. You can check it.
Okay. Thanks.
Are you guys happy with this?
Yes, sir. What about tomorrow, sir?
Right, sir. Not tomorrow, today only. We have another topic.
Okay, okay.
Good, guys. So with this, we are done with most of the concepts in the Kubernetes. I tried my level best to explain you whatever I know in the Kubernetes. So we started. What is a Kubernetes? What is this Kubernetes? Why we are going for the Kubernetes, right?
Sir, last time yes, we have another 2-3 topics, right?
Yeah, those topics are pending. Yeah, so we are done. We are almost done. 95% of the content is completed with respect to the Kubernetes. 2 to 3 topics are pending, guys. That is RBAC, stateful set. That is another one is config map and secrets are available. I will need to explain those topics also. Right. So Kubernetes, guys,
Hello,
can
sir.
we? Yeah, hi.
Sir, I'm facing one issue, sir.
I will check that, sir. 1 second.
Okay, sir.
Okay. Guys, can we summarize what we have learned in the Kubernetes as of now? Can anyone tell me quickly what we have learned in the Kubernetes? Anyone? Any contributor? Can you tell me?
Yes, in Kubernetes, we initially we went through the history of Kubernetes. Then we went through the architecture of Kubernetes, how what happens behind the pod gets deployed or the application gets deployed on the pod. So we went through that, the application deployment on pod, the architecture. Then we went through various service types, the cluster IP, node port, and load balancer. Then we saw ingress as well. And before that, like even we saw that how we can set up the Kubernetes cluster using worker nodes and master nodes. Then we saw that how we can set up the EKS, wherein we can use the Amazon Web Service to get the Kubernetes cluster. And we even saw like there are various stateful set, the daemon set, various types of sets, the replica controller, the how even we saw there are deployment models like green blue deployment model, and there were two more models as well. And
Recreate rolling update.
yeah, correct.
Good.
And the monitoring tools like the Grafana and Prometheus, and even we are currently just saw the how we can get the logs using this Kibana ELK.
Excellent.
We
Excellent.
covered Helm also.
We covered Helm also. Yes.
Yeah.
What is the Helm?
Package manager for Kubernetes.
Use it to, yep, it is a package manager. How we are installing a software in the Linux by using yum or apt package manager. Similarly, we are able to deploy the applications on the cluster by using Helm package manager. Okay. Okay, fine, guys. He just mentioned what are the topics I covered. Can anyone summarize? Suppose if anybody asks you, what do you know in the Kubernetes? So can you talk about the Kubernetes, whatever you know, topic wise? Can you explain what is Kubernetes, why Kubernetes, each topic in the Kubernetes? Can anyone explain?
Sir, can I give the topic summary?
Yes, you can give, please.
Sir, architecture of Kubernetes, then what is pods, what is services?
No, you need to tell me what is Kubernetes, why Kubernetes, what components are there in the Kubernetes, what is the purpose of each component?
Means architecture, sir, total?
Yep, complete. Total Kubernetes, whatever you know, you explain.
Yes, sir. In Kubernetes, for pod deployment, we give the request to Kubernetes API. Then Kubernetes API will give to the controller or something like that. Then it is etcd. It goes to the etcd. Then from etcd, it is key value pairs of the data of the pods. Then there is one. Sir, sorry, sir. I know, but I can't explain.
Yeah.
Can I?
Yes, sir.
So basically there will be a like API server, means we will like using kubectl, we will directly interact with the Kubernetes API server. So wherein like there will be a request will be sent to the API server. So API server will talk like the heart of Kubernetes is the schedule, the etcd data store, where the data will get stored. So based on that, the scheduler will schedule the pod. Basically there will be a kubectl which will like if he sees that the name of that it is written the name of that like pod is to be deployed on that kubectl, then it will get deployed on that. Basically first of all I can there are what are the components of control plane and what are the components of the worker. So the components of master or control node, control plane node are the Kubernetes API server, then there is the scheduler, there is the etcd, and there is a kube control manager. So these are the components of control plane. And if we have to talk about the worker node, then there are the components. The first is the kubectl, kube proxy, the container runtime, and the pod. So these are the components of worker node. So if the pod should be deployed, then the kubectl in worker node, I just mentioned kubectl, but it is not the kubectl, it is the kubelet. Sorry for that. So if I have to mention how the pod gets deployed, then using kubectl, the request will kubectl will interact with the API server. From the API server, the pod, the database will be, what are the details will get stored into the etcd. From that etcd, scheduler will paste the data. Based on the availability of nodes, the scheduler will try to schedule the whatever the pod. So what will happen? The scheduler will the kubelet running on the which is the agent which is running on the worker node, so will see if his name is written on that schedule, whatever the pod we need to schedule. So it will try to schedule the container inside that it will try to schedule the pod. So the scheduler, so kubelet will schedule the pod inside the like there is a inside the pod there will be a container which will be running. So this way the pod will get spawned, and the kube proxy is for the networking purpose, and the container is for running the application inside the pod. So this way the container runtime will be there. So every pod there will be one or more containers. So pod is the basic deployment unit. If you do not have pod, then the application cannot be deployed. You should have the it is the smallest unit, Kubernetes unit. So you must have at least one pod, and in every pod there will be one or more containers. And the pods will share the resources, such as like in one pod there are 2 to 3 containers, then it will be share common resources like storage and network. So this is the architecture of Kubernetes.
Good, sir. Excellent, Mayur. Good job.
Thanks.
Fine, guys. So we discussed about Kubernetes, right? Kubernetes is one of the orchestration platform which is available. It is an open source software only. It is developed by Google. The first version of the Kubernetes came in the market in the year of 2015. Kubernetes is a replacement for the Docker Swarm. Docker Swarm is also a orchestration platform, but in the Docker Swarm, some limitations are available. Scaling should be done manually. To overcome that problem, we are going for Kubernetes. So if we see the Kubernetes architecture, control plane will be available and worker nodes will be available. Control plane is the main component which is going to take care of your deployments, and it is going to control the worker nodes, right? API server, scheduler, controller manager, etcd, pods, containers, Docker runtime, kubelet, kube proxy. API server will receive our request that we are sending from kubectl, and it will store into etcd. Etcd is a database of the Kubernetes cluster. Once the request is stored in the etcd, then scheduler will take that and it will schedule by talking to kubelet. Kubelet is a kubelet is a worker node agent. It will tell the resources availability of the node. Right. Kube proxy will maintain the network connections within the cluster from worker node to control plane. When we want to deploy our application, we are going to create a pod and we are going to execute. Pod is the smallest building block that we can execute on the cluster. If you want to deploy your application on the cluster, for your application, pod should be created, right? Creating the pods manually is not at all recommended because self-healing capabilities and all will not be available. That's why we are going to create the pods by using replication controller, replication set, daemon set, stateful set, and a deployment, right? And we can specify scaling also. We can do the scale, auto scaling also we can do by using HPA, horizontal pod autoscaler, right? So this cluster setup we can do in multiple ways. Minikube, one of the easiest approach to set up the Kubernetes cluster, but the Minikube is giving you only single node. We can't go with multiple nodes, right? So if you want to go with multiple nodes, then we need to go for KubeADM, self-managed cluster. Instead of we are managing this cluster on our own, we can go for EKS cluster, which is given by AWS. EKS cluster is a commercial. They will charge money based on hour basis. Every hour the bill will be generated. Worker nodes bill you have to pay Cluster bill also you have to pay when you go for EKS. Good. The core components of the Kubernetes container. Container is the runtime instance of our Docker image. We are not deploying our applications directly. We are using the Docker as a containerization platform to deploy our application. So for every application, we are going to create one Docker image. Docker image is nothing but a packaging of application and application dependencies. So that containers we are going to run on the cluster by using pod concept. Pod is the smallest building block. Namespaces. Now today we have seen the namespace for EFK stack. So if you don't specify the namespace, by default it is going to run on the default namespace, but it is recommended to run your applications on the custom namespaces. A namespace nothing but a cluster inside another cluster, right? Service. Pods by default, when you create a pod, by default the pod will become cluster IP. That means the pod is accessible within the cluster. If you want to expose the pods outside the cluster, then you need to go for namespace. So you need to go for service concept. There are three types of services available: cluster IP service, node port service, load balancer service. And the next one is volumes. Okay, right. Cluster IP means within cluster, node port means outside the cluster, load balance means when you are going for a provider, then you can use load balancer. Volumes, by default, Kubernetes volumes will be, by default cluster data will be available within the node. Once this pod is deleted or node is deleted, then we are going to lose the data. To make our application as a stateful application, even if the node is deleted or pod is deleted, I don't want to lose my data. For that, we are going for volumes concept in the Kubernetes. Replication controller, replication set, daemon set, stateful set, deployment, ingress, we discussed, right? So what is the most recommended approach to deploy our applications on the cluster? Deployment approach we are going to use. Deployment approach is providing auto scaling capability, that is HPA. Recreate strategy available, rolling update strategy available, blue-green strategy is available. And whenever we are running our applications, we don't expose our applications to the outside traffic directly. We are going to use ingress. What is the purpose of ingress? Ingress is used to route the traffic from external sources to cluster services, right? These are the core components of the Kubernetes. EKS cluster. When you go for EKS, provider will manage the cluster. You just need to create the worker nodes and attach to them. That's it. Helm is a package manager for Kubernetes applications. You can install, you can deploy your applications on the cluster easily by using Helm with the help of chat concept. Chat is nothing but collection of organized files. Chat is nothing but collection of organized files, right? Helm architecture. So when you want to deploy one application by using Helm, we installed Helm client on the cluster. Helm client will take the chat repository. Helm chat repositories are available. So if you go to Helm website, you can get all the repositories. You can add the repository to the Helm client and you can install it. Whenever you install, the Helm is installed on the cluster. So Helm is going to talk to the cluster and Helm will install that application on the cluster. We installed Prometheus, Grafana, Kibana, Elasticsearch, FileBeat, all these things by using Helm charts only. Prometheus is an open source systems monitoring software. Prometheus collects and stores collects the metrics of our cluster. Grafana is a visualization software. It will present the data. It is for cluster. Prometheus, Grafana use it to monitor the cluster data. Then what about application monitoring? Application functionality failing. So if application functionality failing, developers should understand the reason of the failure. Developers should understand the reason of the failure. For that, we need to have the logs. So in every project, Java developers will implement logging. Java developers will implement logging. So when the project is executed, the log file will be generated. The log file will be stored. The log file contains logs of our application. The logs of our application. Okay. Right, to track the logs of our application, we are going to use Elastic Stack, right? Elasticsearch, Logstash, FileBeat, Kibana we are using. Elasticsearch is used to store the logs. Logstash will collect the logs from the applications and will store into Elasticsearch. Logs will be available on multiple worker nodes. So which pod will execute on multiple worker nodes? Daemon set. File beat I'm executing. File beat is a default. By default, it will execute as a daemon set. It will collect the logs from all the services from all the nodes, will store into Elasticsearch. Kibana is providing you a user interface. Using that Kibana, we are able to access these logs. Okay, clear for everybody? Yeah, guys, now I have a cluster running in my EKS from long days. I think I need to pay the bill this time. I'm going to delete my cluster because whatever the remaining topics are there in the Kubernetes, I'm going to demonstrate those topics on the self-managed cluster because I think from last 1 week onwards, my cluster is running. Let me delete it. First, in order to delete your EKS cluster, you need to go to your node group.
But
First,
how much is bill, sir? How much is bill for 1 week if you are using continuously?
this month end I will know. Okay.
Okay. So
No, sir, it is already generated. You
Okay.
can see.
Yeah, it's already
Previous-
generated.
For me,
Why
it
you-
is 2 days, $6.
For 2 days, then I will get almost $50 to $100.
See,
Oh
it
my
is a two
God.
continuous.
$55.
I got $55 bill.
Yes,
No,
sir.
it
For
continuously
that,
up, sir. Or is it is continuous up?
Continuously it is up.
सर वेव ऑफ
Wave off करना है भाई.
हो जाएगा क्या इतना
पता नहीं.
देखते हैं सर
Yeah, let's go to this Kubernetes service, guys. Let me delete my cluster. So here, before deleting the cluster, first you need to delete your node group. So here my node group is available. Click on delete, EKS node group. Delete it. $100 means 7,500, right? $55 means almost 4,000 rupees, something like that. What is the
Now
cost?
it is 8,000, sir, $100.
$8,000 price increased. Huh? Okay, let me take $60 into 80. Okay, maybe 5,000 bill I will get for this month because I used this Kubernetes cluster from last 1 week. Yeah, in order to delete the cluster, first we need to delete the node group. Once the node group got deleted, then we can delete our cluster. Without deleting the node group, you cannot delete the cluster. So first go to your cluster. There you have compute option. In the compute node group is there, 2 nodes are running. I have created a node group with 2 minimum count and maximum I have given 5 count. Okay, my node group is still under deletion. Once this node group got deleted, then I will go and delete my cluster.
Sir, is there any recommended approach, sir? Like to work with EKS and to reduce the bill?
Sir, for practice purpose, you can use Minikube and you can work with that. You can practice all these things with Minikube. That is just for learning purpose. But in the real time, we will go for this EKS clusters. Companies will pay client will pay the money for infrastructure. Na? Yeah. But if I explain everything with the Minikube, you will not get this much clarity. How multiple pods will be created, how multiple nodes will be available. You will not get this much clarity.
also sir load balancer not work on the
Load balancer will not work on the self-managed clusters. But I don't know how other trainers are teaching, whether they are teaching on the cluster or they are teaching on the self-managed. I don't know that. Anybody, any of your friends learning DevOps outside?
What they are using, sir? What by Node? No, they're using Nginx front end. Okay.
Sorry.
Node, no, they are putting front end as Nginx.
Okay. Okay.
They're configuring node port. They're not giving the directly as load balancer on the manifesto file. They're configuring on the node port and they are configuring load balancer using the Nginx.
Okay. Okay. So I hope you guys are confident on the Kubernetes now. Confidently, can you keep Kubernetes on your resume?
Yes.
yes sir
Hello, sir.
Hi, sir.
Hi, sir. I have one doubt, sir.
Please tell me.
Yeah, Helm is there now. Kubernetes manager, package manager.
Yeah.
There we have the custom application is there.
Yeah.
We want to add Helm add repo is there now. How
Yes.
to add that application to Helm, sir.
So no, you need to create a Helm. There is a option called Helm creation. When you
Yes,
create the
okay.
Helm, it will generate the directory structure. There you need to keep your manifest files. So there you need to create a custom chat. If you are for your application, if you want to manage with the Helm, you need to create a custom chat for that Helm by using Helm create option will come. You see here. So whenever you create a custom chat by using Helm, this directory structure will be created. In this templates, you need to create your deployment files.
Yeah, I created like that, but I have to add repo, Helm add repo. I have to create Helm create chart means we have created one chart and we can default is Nginx is created.
Yep.
And on that we have to change what are your application. We can keep it that. But another way is there na Helm add repo. We have to metric server. Before that we added a metric.
Those are
metric server,
predefined.
na?
Those are predefined repositories available in the public, right? For your application, the predefined repository will not be available, na?
Yeah. So
You
we have
can't.
to create. Okay,
Huh.
that's why we have created just here is there.
Yes.
Helm chat. The tree structure is available here. Like we have created one template Helm create. Then we have to
Yes.
create a Helm chat. Under Helm
Yes.
chat, all those things available and templates, chats, and
Yes.
YAML files and
Everything
service.
will be
Yeah.
available.
I done that, but Nginx default one is created as a Nginx.
Right.
Yeah, Nginx under we have to write what are the our image is there. We need to write there.
Right. We need to write there.
Yeah, we just modify there. That's it. Not more
Right.
than
That's
that.
it. Not more than that. So see here,
But
whenever
what
you
are the
create whenever you create the Helm, you will create a name for your Helm chart, right? So you are going to give Helm upgrade. You will give your Helm upgrade install. You will give your chat name.
Yeah, here. Okay, Helm install. Chat
Yes.
name
You
is
will.
before that
What?
we have done a Maven project, something Maven or before that we done one application we have taken. Maven.
Right.
Yeah, we need to write here.
Right.
Helm upgrade hyphen install Maven app web apps. That's it now.
Well, whatever the chat you created by using Helm, that chat name, if you give, then it is going to install on your cluster.
Okay.
Right. Let
Yes,
me
sir,
check
try.
mine. Good.
Hello, sir. Can you show one our created our means user-defined project in using Helm?
Sure, sir. I will try that once. I will need to create the manifest and I will try.
Once you show, we will get some idea.
Sure, sir. Now I'm going to delete my cluster. Finally, EKS cluster 2. Click on delete. Now it will take some time, guys, to delete the cluster. EKS cluster 2 I'm trying to delete. So this cluster will be deleted next time. So whenever I'm going to talk about that RBAC or the remaining stuff, some 2 to 3 concepts are pending in the Kubernetes, right? Those topics I will explain by using self-managed cluster.
Sir, check NAT gateway also. It is creating billing.
NAT gateways, huh? In the VPC, I will
Yes,
delete
sir.
that VPC also, whatever the VPC. Basically, VPC is not a paid service. VPC is a free service only.
But NAT gateway, it is creating billing.
Okay, I will delete those also.
Yes,
Two
sir,
NAT
too.
gateways are available. For these VPCs, two NAT gateways created. I will need to delete the NAT gateways and I will delete the VPCs. I will clear all my infrastructure. Two VPCs are available. One is a default VPC and one is the cluster VPC. We created this VPC by using CloudFormation in the AWS, right?
Yes, sir.
Good.
Sir, I am facing one issue that I am using node port services to accessing Prometheus and Grafana.
Yes, sir. In the node port, they are not working, sir. They are working with the load balancer only directly.
No, sir. Grafana I can access, but Prometheus I cannot access.
1 second. Let's check it. ELK stack. Okay, fine, guys. Now, in the tomorrow session, I'm going to explain you how to work with Nexus repository. And I will show you resume preparation All those details I will take in the tomorrow session. Tomorrow morning, we have a class at 8 o'clock. Okay, I will share the new Zoom link for tomorrow session, guys, in the Telegram group as well as in the portal. Also, I will update. Tomorrow we have a class. Tomorrow we have a class at 8 a.m. in the morning, guys. So tomorrow, Sunday evening, I think you people will have some plans to go outside. So I will take the session tomorrow morning at 8 a.m. Tomorrow morning, I'm going to talk about Nexus repository, which is one of the important concepts for DevOps engineers, Nexus repository. And I will share sample resumes, resume preparation also. We are going to do this. And so one project with Jenkins, Docker, Kubernetes integration, I will take on the next weekend. So I'm giving you 1 week of time for a practice. Next 30th and 31st, or next 31st, I'm going to take a project session. Project session I'm going to take on 31st July 2022. So this session also on Sunday. So this will be on the morning only. Sunday morning at 7 a.m. or 8 a.m. IST. I will be take this project session. What are the roles and responsibilities of the DevOps engineers? So all those things we are going to resume preparation, roles and responsibilities. Roles and responsibilities of DevOps engineer that I'm going to take in the tomorrow session. Tomorrow we have class morning at 8 a.m. IST, guys. Please make sure you are attending that session. So tomorrow we are going to talk first what is a Nexus repository and how to work with Nexus repository, where we will use that, and how to prepare a resume with the DevOps and AWS. And I will share some sample resumes also. And I will be talking about roles and responsibilities of the DevOps engineers in the company. And we will be having our final session on the next Sunday. So this next 1 week, you will have a time to practice all the topics that we discussed in the DevOps. We learned so many tools in the DevOps. We learned so many services in the cloud. So take 1 week of time and practice. Next Sunday, we will do one project setup, and the remaining topics on the Kubernetes also I'm going to talk on next Sunday. Is it clear?
Sir, New Relic also you will cover, no, sir?
New Relic I will see, sir. So I will let me check it once. How to add the New Relic to
Please give some brief on that, sir.
Sure, I will give some an idea on New Relic. New Relic is application performance monitoring software.
Yes.
Yeah. Clear, guys? So tomorrow 8 a.m. a class is there. I will share the new Zoom link in the Telegram, as well as I will update that in the portal also. Okay, fine, guys. Thank you. With this,
Hello?
I'm stop. Yeah, yes, sir.
Sir, now it is working.
It's working, that node port, huh?
Yes, sir. Yes, sir.
What was the mistake?
Sir, don't know. Like same thing I did evening also. It is not working, but now it is working, sir.
Okay, fine, sir.
Sir, before we are using HTTP. Before typing IP, you need to use HTTP.
Yeah, right.
So actually, a little part of Docker Compose is also left. So is it
Yeah,
important for
that
us?
is in the project only. I am going to mention that a project I'm going to take with a database also. When we are going to use the database in the Compose, we are going to specify 2 images. There I will mention that.
All right.
Hello, sir.
Yeah, hi.
Yeah, hi, sir. Sir, actually, some of my friends, they want to join your DevOps batch. So when is your next batch, sir?
Yeah, next batch is starting from 28th, sir. 28th, 9:30 a.m. the DevOps batch is going to start. This time Linux, DevOps, then at the end they will see AWS.
Okay. So it will
Because
be fixed time, 9:30 every day?
9:30 up to Linux, sir. DevOps will start morning at 8:15. After Linux is completed, they will attend the DevOps from 8:15 a.m.
Okay. So 8:15 also and 9:30 also. 2 batches they will have to attend, sir?
Yes, sir. No. 9:30 will be available only up to Linux.
Okay.
Yeah, after Linux is completed, regular DevOps classes will be available from 8:15 only.
Okay. But sir, syllabus would be same, no? It's just
Same
that
syllabus. Same syllabus.
all
same
Docker,
syllabus.
Kubernetes, whatever you covered for us.
Everything will be same.
Okay.
28th July. Yes, 9:30 a.m. Already I shared the poster in the Telegram. You guys can check it.
So,
Would
Then
you
you
be
will
covering
cover
all the would you be covering all the projects on the upcoming weekend on that day only?
Yes, sir. I will cover those projects on that weekend.
All right. Okay.
Hello, sir. When will you cover that pending topics in our Kubernetes?
Yeah, that's sir. That is what the next coming Sunday I'm going to cover those topics. Those topics are very simple, sir. It will take 1 to 2 hours of time. After those topics are completed, I will explain the project. What are the topics are pending? We will use them in the project directly.
And sir, one another thing is pending. We have one Kubernetes dashboard. We need to give the
Right. Instead of kubectl, directly from the dashboard
yes,
we want to manage.
We
Yes,
can
sir.
use
I will show you
dashboard.
that. Right.
Sir, apart from everything, thank you so much for covering so many things. It is really
Yes, sir.
useful,
Thank you.
sir.
Thanks a lot, sir. You did
Thank
a
you,
great
guys.
job for us.
Sir,
Thank
that
you,
is the reason we are referring so many people. So they attended some other sessions also, but they wanted to join your session only. So whenever your new batch start, they will be joining.
Thank you, guys. Thank you. One thing
Thank
that
you, sir.
happened for this batch is I took a lot of time for AWS initially because
No
of the
problem, sir.
preparation.
No problem. We learned so much. That is much appreciated, sir.
Yeah. Thank you, guys. Thank you so much for your patience, for spending this much time with me. So tomorrow is very important. Repository, resume preparation, roles and responsibilities. I will share the link in the Telegram as well as I will update in the portals. Please don't miss the tomorrow session. Okay.
Okay, sir. Thank you,
Thank you,
sir.
guys. Thank you. Good night. We'll see you
night,
tomorrow
sir.
morning. Tomorrow morning, 8 a.m. 8 a.m.
Okay.
Sunday. Yeah.
Thank you, sir.
Thank you, guys.